This is number 6145 in our homework for lesson 6.1, where we're asked to use this data and construct the 90 and 99% confidence intervals for the population mean. Then we'll be asked to identify which is wider in the end. So first we need to remember our basic formula for constructing a confidence interval for a mean from a sample, but we do know the standard deviation of the population, sigma. And so this is an example of a z-interval for a mean because we do know sigma. So first, our confidence intervals for means come in the form x bar plus or minus margin of error. And our margin of error for a z-interval for a mean, we've learned, is the critical value times what's called the standard error. We take sigma and we divide by root n. So our critical value for 90% can be found in our infinity row of our table of critical values for the t-distribution. So we go to 90% confidence and then go all the way down to the infinity row, and we find that our critical value is equal to 1.645. That means that in a normal curve, we need to go out 1.645 standard deviations above and below the mean to capture the middle 90% of that curve. The rest of our error, we're going to need to take that 1.645 and divide by sigma over root n, or multiply, by sigma over root n. We've been told that sigma is 1.8, and root n would be root 15 in this case, since there are 15 numbers in this sample. So when I calculate the value of 1.645 times 1.8 divide by square root 15, I get 0.7645. That is my margin of error, 0.7645. Now, the rest of our interval comes from calculating the average. That's called our point estimate. So of course, to get an average, we just take every value of our data set, add them up, and divide by the number of pieces of data. So we're going to take 8 plus 12 plus 11 plus 6 and so on, all the way to the last piece of data, 11, get a total, and then divide by 15 since we have 15 numbers in our set. And when we do that, we get an x bar equal to 8.8. All right, so we're almost there. We now are going to calculate the lower end of our interval and the upper end of our interval. The lower end will be the x bar minus our margin of error, and the upper end will be the x bar plus our margin of error. So our x bar minus will be 8.8 minus our margin of error rounded to the nearest tenth, 0.8. And our upper boundary will be our 8.8, our point estimate, plus that margin of error. So our confidence interval will go from 8 to 9.6. We can say with 90% confidence that the population mean number of, or mean length of time that all adults spend reading the newspaper is somewhere between 8 and 9.6 minutes.